Another draft physics video production. I have a feeling something might have gone wrong, so I'm going to check to see that it's not saying anything stupid. It appears to be using megabytes, so okay, it's working. Anyway, yeah, I'm back. Again, more insufferable whatever this is, this whole interacting with stupid humans. It's just the way it is. The world's just covered with them. Anyway, you just can't swat them out of your way. They're just incessant. So we will get to the Silence Asylum eventually, another dopey video by that dope that I got to by watching a Fractal Woman video where she's using all of Ken Wheeler's jargon, incommensurability and all that kind of crap. All this wooey bullshit. And so I was going to do a Ken Wheeler video, but I won't bother with that. We'll wait for another day. But they're just getting sillier and sillier, and he's clearly a religious kook, and he just won't out himself. These people don't really ever use the word evolution. I don't think, they're... I guess this is the new way of being a creationist, is to just hide the fact that you're a creationist and pretend you're just doing science. It seems to be the game being played. But anyway, so here's another idiot defending an idiot. Looks just like Ken Wheeler, of course, right? Fat and bald, so you're just saying, oh, that's what it's about. He's just identifying with the fat, bald guy who's succeeding. As a duper of fat, bald people, apparently. Apparently there's a lot of, well, there's no point in saying, it's no point in the generalization, it's useless information. Fact is that these are brains that somehow are susceptible to absolute crap, and they say, oh, gee, that was brilliant, because they have no capacity to judge, because they have no knowledge of anything. They're idiots. So there's a lot of idiots in the world. You really need to look. I didn't even try in school. I gotta tell you, I didn't even try. And I absorbed apparently zillions and zillions of megabytes more information than people who were trying. Shit. You really need to look a lot more at his videos. I've seen hundreds of them before you start to get what he's talking about. He's not talking about anything. He's talking about some sort of bullshit he's cobbled out of other people's bullshit. So other people said some wacky shit in the past and drew a wacky picture, and he's just taken a bunch of wacky pictures and thrown them together into some sort of mush that's just that, mush. It's mush. It's just a whirlpool of mush. If you want to take an atomistic view of the world, what does that even mean? Yes, I want to take a logical, rational view of the world and the universe and everything else, and I see the moon and I see a bunch of craters on it, and my assumption isn't, magic did it, dragon footprints. So yeah, I'm doing the 2 plus 2 thing. I'm not doing your wacky 2 plus, ZW, plus whatever, Zog. Fuck you. Of the world, be my guest. Well, if you want to take an irrational view, a magical view, a dragon view, don't be my guest. I hope you trip and fall catastrophically, because you're not doing the world any good talking this shit. Alright, but it doesn't explain what's going on. Well, again, I have explained what's going on, so fuck you, and you won't be able to refute any of it as being totally consistent with the evidence, so fuck you again. More shit talk from these people. They put up nothing. They just claim, I've debunked you. No, you haven't done anything. Let's see, but it doesn't explain what's going on and what we can see in simple experiments. No, it perfectly does. That's why they called it mock gravity. It's because it perfectly works to explain gravity. It's a perfect model of how the flow of the momentum happens, to use one of their magic words. All the other scientists from Maxwell to Tesla before Einstein were talking about ether. Yeah, and all the other humans before Darwin were talking about angels and and fairies and demons. So what? Yeah, retards. Quantum theory, or the latest version of the atomic atomistic theory. So again, this bullshit. You have to cite who you're talking to, because every one of these physicists, has a different view of quantum mechanics and different interpretations. And so this is just sort of horseshit to say what their theory is. The generalization is that they don't care about getting the theory right. They just care about having working equations. And so they're really not someone you can argue their theory, because they don't have a theory of function. They just have mass of function. They just care about what you can see. I mean, events, effects. They don't care about causes. Has gotten more and more complex to where we've gotten to dark matter and quantum fields fluid. You might as well just go to the leprechauns and the unicorns. Well, again, so this is another straw man bullshit argument. The fact that the electric universe, for example, is wrong doesn't make Ken Wheeler right. The fact that somebody else is wrong doesn't make something right. So again, what are you proving? I can prove that, yes, conventional physics is full of shit, and I've stated it overtly. So again, what's this? You're preaching to a choir already. The point isn't whether they're wrong. The point is you're claiming they have some sort of atomistic view. Well, obviously it's not very atomistic if electrons are waving. I mean, if they're not even in any location, that's not very atomistic, right? Their view isn't very atomistic if they're saying quantum says that it doesn't have a fixed position in space and time. That's not very atomistic, asshole. So your generic diss of anyone who thinks in terms of elemental function being particulate and stable and simple, that's not their description. So they might say they're doing particle physics, but again, show me any particle they have that's actually a particle. I mean, you wouldn't call it an asteroid if it blipped in and out of existence and it popped all over the place and did some magical shit. You wouldn't say, oh, that's an asteroid. No, you wouldn't say that, would you? What makes more sense, fuck you, is it is a pressure mediation. Well, duh, that's exactly what I've said in my videos, but obviously it has to come from somewhere. The pressure has to be made of something. So what are you making it out of? Bill Gates has some dopey notion that there's ropes. How do they make pressure? He's just creating another ether out of rope. You have to explain, even if you're going to have an ether, how the pressure got there. And the clear implication is all the pressure comes from the ether. It doesn't come from someplace else. It has to be coming from space itself. And that's the part you assholes haven't figured out yet. Okay, this argument really isn't, who cares what the medium is if we all agree that the little bits of energy are small, okay, and they move through something that might be called space or dimensionality. They're not all over the place. I mean, do you believe that everything is everywhere now? Right now, this battery's not right here. It's on Venus. I mean, fuck this shit. Let's see. And that gravity, electricity, and magnetism is all expression of the same field. So again, but that's not what Ken Wheeler's talking about. He's calling out, he's got tornadoes and whoop-de-doos and all that. Where's the energy coming from for any of that shit? That's the part you have to explain. If you're going to claim that it's swirling and dirling and doing all this crap, you have to explain how the fuck it's doing any of that shit. Period. And then he starts a sentence, and if you took the time to listen, fuck you in the ass till dead. It'll take a long time because you've got a big fat ass. And if you took the time to listen, that's a brass gyroscope, not very easy to induce a current into. Completely idiotic. I mean, brass is a very good conductor, so it's just idiotic. It's completely paramagnetic. So fuck you again, idiot. Oh, shit. Okay. Only a year and a half for me in. Can't wait for my thanks for watching 5 years lapel pin. Yeah, well, it's a pretty good joke. Yeah. I'll put it in the mail. Yeah, maybe. Anyway. Yeah. What do you want me to say? It's very nice, okay, you find some reason to listen. The point is that this is a real dilemma, because even when you attempt reasoning, I mean, you put the facts on the table, people are just unreasonable. And they're totally unaccountable cowards. They won't defend their mush. None of them have the guts to argue it. It's quite obvious. So anyway, so this is how I got into this mess, was watching this fractal woman video. Oh, I did watch a little of this Thunderbolts video. I mean, look at these graphics. Look at the hand of God and electricity. I mean, they're so full of shit. Oh, well, anyway. Alright, so let's just do this. This is just so bad. And I will draw as necessary, but I don't even think it's necessary to draw this. I mean, this, well, anyway.
All my intuitions about circuits. Prepare for a mind blow. This episode was made possible by generous supporters on Patreon. Hey crazies, one thing you cannot do is confuse the motion of charge with the motion of energy.
Yes, and you shouldn't confuse the fact that a charge moves. You shouldn't assume that that means it has special properties. No, it means it moved. And if it's doing something when it's not moving, and you move it, that means the thing that it's got is moving with it. So let's say there was an Enterprise starship and it had a tractor beam, right? Well, and the tractor beam was always on, or the shields. It has shields, you know, whatever they are called. Those move with it. So if it moves, the shield moves, or the tractor beam moves, or whatever it's emitting, it moves with it. And so if that emission thing is what we call a force, the force is moving with it. And the force now can crash into you. You can be hit by it. So if a light bulb is over there, it's not very bright. And I can move the light bulb closer, and it gets brighter and brighter. And the closer I bring it, it gets brighter and brighter. So the light moves with the light bulb. And if I have something like a piece of photographic paper or something, the photographic paper can get all exposed because the light bulb moved. So something else can happen over here because that thing moved. But if it stayed where it was, nothing would have happened, because not enough photons were hitting it.
They are not the same thing. Let's define them both very carefully.
There's no careful in any of this shit, because you're not even going to define any of these things as being real things. They don't really exist, this electric and magnetic field thing, as distinctly different fields. It's all one field, as the other kook said. But anyway.
Current, or just current for short, is the flow of positive charge.
So again, he's playing a word game now, because Benjamin Franklin got it wrong. We're going to play a game and stick with his bad language, you know, positive. It's obviously the high pressure is the negative, the low pressure is the positive. You know, it's backwards. The pressure always moves from high pressure to low pressure. The high pressure means there's more things punching. It's innately more, they're not like two opposite things in some sort of benign way. They're opposite in a fundamental way, and the one thing is doing the hitting of the other thing. Okay, big things squish little things. Little things can't squish big things. I mean...
Wait. Positive charge? Yeah, you can thank Ben Franklin for that. To the timeline! Back in 1748?
So this is like, he's doing this intricate playing with, you know, Maxwell's equations. He's going to play with the jargon in the equations. So it's kind of a complex concept. And then he's going to do this timeline crap in the same video. So he's going to do something as stupid as explain to people that, look, plus and minus were wrongly assigned, which anybody who could understand anything about Maxwell's equations or the complexity of the Poynting vector or any of that crap would obviously already know. And anybody who needs somebody to tell them that, you know, Ben Franklin did the plus and minus thing wrong, obviously isn't going to be able in less than 7 minutes to understand a fucking thing about Maxwell's equations. It just ain't going to happen in 7 minutes. So this is useless. Either make the video for people who know the physics, or stick to subjects you can explain in 7 minutes.
Ben Franklin stated two things about electricity. One, amber becomes negative when rubbed. And two, current is the flow of positive charge. Then...
Right, and obviously he had it inverse, and he understood that the flow is in the one direction. He didn't make any assertion that voltage goes one way and current goes the other way, or any kind of crap like that because of a wrong assignment. So in his day, the assignment worked because nobody had figured out the difference between these. Well, I can't say that nobody had figured out, but obviously they hadn't got to volts and watts and all that stuff when he was just basically discovering the fact that it tends to move from this thing to this thing. It moves in a direction, it doesn't move in both directions, and he knew that for fucking sure. So let's not say he was, because he wrongly assigned which one had the pressure, that he somehow thought it would make sense in the future to have the voltage go one way and the current go the opposite way because of that wrong assignment.
150 years later, J.J. Thomson discovered the electron, and we realized we had a problem. You'd think we would have adjusted one of Franklin's definitions, but we didn't. We doubled down on them instead.
And you're double downing on the same mistake. So again, this is what physics does. Instead of fixing it from its origin where it's broken, they just keep making it more and more complicated by keep putting in gimmicks to fix the broken. And he's gimmicking again. He's taking the gimmick that exists to fix the broken, and he's redoubling on that gimmick to say something that's totally idiotic.
Even though we know negative charge is what moves in a current, we pretend like it's positive charge moving in the opposite direction. Human stubbornness will never cease to amaze me. Anyway.
And you're doing the same thing. Again, it's just so funny. You're doing exactly the same thing. You're taking that broken gimmick, and now you're playing on top of it. So instead of fixing it, you're building another pile of crap on top of it.
We have to live with it now. Electric current is the flow of positive charge, and we measure it.
So it's not the flow of positive charge. So that you did, instead of fixing it, you're just reasserting the error. Bravo.
In amperes, or amps for short. The energy flow, on the other hand, is best described by something like power.
No, it's not. It's best described as energy flowing. Okay. So look, this was understood. Even most people should have been taught this in school. But I mean, the two terms are really kind of easy if you just think of them in terms of volume, and you think of them in terms of pressure. So voltage is the amount of pressure in a water hose, and current, okay, is the amount of water molecules moving through the hose in a given amount of time. So you can understand that, yes, well, it's not really the flow, because then that would be all you need for the power equation, actually, if you put time in there. But anyway, it's the volume, okay? So the volume. So you can just think of it in a conductor or something. You could say voltage is the pressure, that is how much is being exchanged. Like, are you exchanging $10 bills, or are you exchanging in $1 bills? So you can think of it in money terms. If I have to use money, if I have low voltage, then it's like I'm using dollar bills. So I've got to use a lot of dollar bills to make any kind of amount of money. But if I increase the voltage, then I'm using $10 bills and $20 bills and $30 bills. So I don't need to make as many exchanges. I don't have to use as many atoms. So you can think of it as, if you use a low voltage, you don't need as many atoms to transfer the amount you're transferring. And if you're using if you're using $20 bills, you don't need as many bills to make the amount of power. So the power is the total amount of money. The denomination of the bill is the voltage, and the current is just what it's going to take, how many bills you're going to have to pass to get to that amount of power.
That's basically how fast the energy is being used, and it's measured in joules per second, or watts. Turn down for watts? Anyway, current and power are related to each other. Since current...
So yes, and so is voltage in a sense, so you can't get around it. The two things are, you can't get around the fact that the pressure in the hose is going to decide how much water's flying through the hose, right? How fast the water moves. And how much water you can put in the hose is going to tell you how much current you know. But the current is always going to be connected to the pressure ultimately. Without pressure, there's no current. So obviously you have to have the pressure first to have any current. And the higher the pressure, the less current you're going to need. The less volume you're going to have to push through the hose to get the same amount at the end. So you have to think, I mean, there's no analogy that's perfect. So the money analogy only fails if you fail to see that the bills are of different sizes. You know, lots of $1 bills have to go through. Very few 20s have to go through. Even less 50s.
Is charge over time, and voltage is energy per charge. Power is just current times voltage. It's a relatively easy calculation. But
yeah, so we don't even need to do a relatively easy calculation. You can just understand it as volume and pressure. How much are you pushing, and how much volume are you pushing? There you go. Obviously, that will decide how much stuff is at the other side, right? I mean, how do I say it again? I mean, whether you're pushing heavy boxes or really light boxes, and you're really deciding how much weight is going to fall off the end, you know. So if you're pushing heavy boxes, it's going to be more weight. If you're pushing light boxes, it's going to be less weight. And if it's light boxes, you got to push more boxes to get the same amount of weight. Yeah.
Our original question isn't really about amounts. It's about direction. This equation...
So again, and we know the direction is all fucked up because of Franklin. So all the equations are backwards and screwed up because the idea of which direction it's going in has to go with, obviously, from high pressure to low pressure.
Tells us nothing about direction. But isn't the energy carried along by charged particles? Won't the current and the power be in the same direction? Well, yes to the first question, but no to the second.
So won't power and whatever be in the same direction? Of course they're in the same direction. And well, anyway, his answer is so stupid. It's not like he says it's moving in the opposite direction. Now they're turning this into this magic bullshit again, where it's just a complete fairy story. Like, well, I'll let him do the fairy story.
The charged particles do have energy because, well, everything has energy. But that's not the energy that's powering whatever device you're using.
Alright, so again, this thing that it has, the charged particle has energy. It has no energy, right? The charge, as I've explained, the charged particle is nothing until you put another charge. You can't tell the charged particle is there. It's doing absolutely nothing until you put other charges in the field, because that's the only way you're going to notice the charged particle is there, is because how it's going to affect other charges. It doesn't affect anything that isn't charged, but obviously everything elementally is charged. There's electrons and protons, and that's all there is. I don't need to draw yet, I don't think.
Let's say for the sake of simplicity, it's just an incandescent light bulb. What I'm about to explain will be true of everything, but we don't want to get caught up in unimportant details.
Right, the unimportant details like being just applying to regular details. I mean, these are details. They're fundamental to the function. You're claiming some new function, so I guess you'd have to be kind of detailed about what you're talking about. Do you know what an electron is? Do you know what it does in a conductor? Do you have any idea? No, I don't think you do.
On the same note, let's power that light bulb using a simple battery. The positive end has a higher energy than the negative end.
Alright, so he's saying that merely because he's reinforcing Franklin's wrong. So he's just again doing what he should fix. And so we know there's not more pressure in the positive end. We know the positive end is actually the end that has lower pressure, and the high pressure is in the negative. So to say it's high energy is just saying it backwards on purpose, because they've used the gimmick to fix it, and you're not going to use the gimmick now. So now he's taking away the gimmick that fixed that problem by, instead of using voltage or some other term, he's using the term energy. It's just bullshit. The energy can only be understood as pressure, and you would never say something that's high pressure is low energy. Ever, ever, ever would you do that. You'd never say that something that's hot is low energy.
So if you give the charges a path, they'll fall to the lower energy.
So more bullshit. So obviously if we give them a path, they're not going to do that. They're going to do exactly the opposite. We know that. Why is he reinforcing an idea that's wrong? So instead of fixing Franklin, he's going back to Franklin. What is that? I mean, it's just he points out how he got it wrong, and now he's sitting there going back to it without the mechanical fix we already threw in there, knowing that the electrons are under more pressure when they're on the negative. That's what the negative end means. More electrons. The electrons hate each other. More pressure. So he's overtly denying what Maxwell fixed, essentially.
Electric current is. Over time, we know the energy in a battery goes down as we use our devices. It can cause...
Well, yes, we know the pressure. We lose pressure. We only have... unless we have a machine that keeps pumping, can keep pumping the pressure, we know the water will stop coming out of the hose if we turn the pump off, no water in the hose. Duh. So again, something this rudimentary, he's throwing in a video where he's going to explain the complexity of Maxwell's equations. Not that they're complex equations, I'm just saying the complexity in the fact that there are a whole bunch of assumptions. You have to look at Maxwell's equations and you have to put assumptions in them. There's no definition of an E field. There's no definition of the B field in terms of a description of its function beyond the rules Maxwell established for its function. So if you don't understand those rules, you can't understand the equation. There's nothing to put in the equation. The variable doesn't mean anything. E doesn't mean anything unless you understand the context in which E exists. And the context it exists in is rules about the flow of electricity through wires. And they're the opposite rules to Ben Franklin's rules, obviously.
Sheer panic when it's the battery in our phones. But the same thing happens with the light bulb, too. The energy in the battery goes down as the light bulb emits heat and light.
So why would anybody need to be told that? I mean, it's just an amazingly stupid piece of crap thrown in here to make this somehow, look, I'm not being completely insensible and irrational. I'll tell you something rational, and then I'll tell you something irrational. So I'll tell you about, there's this animal called a pig, and it, has a funny little flat face, and it snorts. And then I'll start talking about dragons and unicorns. Just to make it sound credible, right? I mean, oh yeah, well, you got that pig part right. Maybe he's right about that dragon shit.
Flow of that energy is described by something called the Poynting vector. No, it's not a typo. It's named after John Henry Poynting, the guy...
And let's understand, it has nothing to do with really being a vector or any of this kind of stuff. It just has to do with math, okay? It's just a mathematical concept. It's not pure geometry like it sounds. It's pointing because his name was Poynting.
I came up with it. It is a pun though, because it points in the direction of energy flow. I love puns. Anyway, here's the Poynting vector. E is the electric field, B is the magnetic field, and...
Right, so you have to have the assumption, right? This new thing is the mu is the permeability of free space, which isn't even a real constant. That's the one that the speed of light is hidden in. And so these are pointing vectors as it is. So these are abstractions. They're not even real mathematical things being multiplied or something. This isn't real multiplication. This is vector math, which is completely different.
Mu is just a constant to make the units come out right. Don't worry about that too much. That gives us the energy flowing through an area every second. A common use of this vector is with light.
So this is the assumption that has to be in your understanding before any of that formalization can make any sense, is that you have to bisect these force carriers into two different entities, okay, with perpendicular elements. So you have to have some notion that somehow there is some sort of real electric field coming off of photons and some real magnetic field coming off of photons, even though there's no indication that any such fields exist in association with them at all. They're created by those kinds of mechanisms. They are not themselves those kinds of mechanisms. So again, it's just more just built out of stuff that hasn't been demonstrated with any evidence to even exist.
Light is an electromagnetic wave, a disturbance in electric and magnetic fields that results in a flow of energy. from a
So anyway, there's no field disturbances. None of that crap has happened. They're photons. Okay, we're talking about things that are real. It's real energy. Okay, it's real stuff that has momentum, and it's transferring momentum. So momentum is what's being transferred. You know, you have a turbine on this end spinning, and then you spin a motor on this end. I mean, you're really transferring motion, and the motion is in the form of pressure, and the pressure is in the form of electrons being pushed, and you can't push an electron into another electron unless you have a force pushing it. So obviously the force is what's being transferred from one electron to the next electron to the next electron to the next electron, which is the same as saying it's being transferred from one atom to another atom to another atom to another atom.
Oh, that looks.
They're just transferring the money, the pressure. $20 bill, $20 bill, $20 bill, $20 bill. And technically the way it's being exchanged though is that this one's got a $20 bill and this one's got a $10 bill, and they're balancing it out, and so this guy ends up with $15 and this guy ends up with $15, and then this guy loses another $5 to the next guy, and then so he can get another $2.50 from this guy, and so it's really just a neutralizing of the pressure, an averaging of it.
Something like this. But the Poynting vector is true for any electric and magnetic fields, not just the ones you find in light. What's the deal with those fields again?
Yes, those fields have never been demonstrated to exist as different fields. There's no different form of energy. The energy is only in one form, and the form is like a virtual photon or a photon. That's the force carrier. By science's own admission, it has every property of a photon. That's what the energy is. The force. Light is a force. Magnetism is a force.
I guess I could do a quickie review. Charges affect the
Electricity is a force in a conductor, in a tube.
field, and moving charges affect the magnetic field.
All right, so this is just something they made up as a mechanism. Now it works in that you'll still conserve the force through the process and all that stuff, but it's a wrong diagram of what the force is, because he's not drawing the atom. Clearly, to have anything electrical happen, you have to have the whole atom. You can't just have a proton. You have to have the electron. Because it has to be a dipole. You have to have dipoles to create magnetism. So obviously there's no disturbance in the field and none of this is going to happen unless you have real atoms to carry it for electricity.
These fields are not attached to the charge. They stay attached to space while the charge moves.
Right. So this isn't their description of this wave stuff, and their understanding that the moving charge is somehow creating the force, when movement has nothing to do with creating a force. It just has to do with changing how close electrons are to each other. So if you move electrons closer to each other, then they're under more pressure. And that's all it has to do with. It doesn't have anything to do with them themselves gaining energy from moving itself. If I could move an electron through free space, it's not going to create any magnetic field, because it's not going to be part of any dipole. It's not going to change an atom from being a positive atom to a negative atom. It's not going to change its size or its dimensions. And that's what makes electricity possible. There is no electric field until you have a dipole. You first have to have the magnet, so to speak.
Are around, the fields are still there. They're just zero. A similar thing happens around the battery.
So again, there's no zero field. So that's again the delusion that somehow if I'm between the Earth and the Moon, the exact right location where I'm being equally pulled towards the Moon and equally being pulled towards the Earth, that there's no force. No, there's plenty of force. It's just equal. It's neutralized. So just bullshit. You wouldn't say it's zero. No, charges do the same thing all the time. They don't change any. The difference is that they affect each other in completely inverse ways, but they have to be affecting somebody else. Well, let's just draw it one more time. Again. Yeah. One more time again. All right. So the idea is... I should have hold the top off of that. Alright, so I have an electron, let's say. I'll just use it because it's easier to use, I suppose. It doesn't really matter. You have two kinds of force. You have this red stuff coming in. Alright, that's the proton force. Proton would be red. And you have this stuff called the electron force. Okay, so the universe is just made of this, like the cosmic background radiation. This stuff is always in the universe, and every object in the universe will be hit with a certain amount of this stuff depending on what else is in their vicinity, right? So if there's something else in the vicinity that's going to absorb certain one of these arrows, then it can have it'll change the field that something's in. But this is the field it's in, and what's happening is these little black ones are just reflecting off the electron straight back, and they give the electron momentum in the direction it was going. So it's an exchange. An arrow going this way goes into the electron gives back an arrow going that way, and it changes what it has inside of it. So if it had 5 going this way and 3 going this way, well, now it'll have 6 going that way and 2 going this way. So it just changes its orientation as a boat, or if you could describe it that way. Well, I've already done all these descriptions. Well, the key difference is so the black things reflect and cause momentum, and the red ones just passively go out in a new direction. Perpendicular, I would argue, and perpendicular can be any one of the 4 perpendicular directions, but basically they just go in and come out. So it looks just like a reflection. So everywhere it's going to look the same around a proton and an electron when they're by themselves. They're going to be emitting, okay, exactly the same amount of force that goes in. They have equilibrium. They are conservative in how they affect the field. The key is that when you put another black thing in here, all right, what you're going to cause is these reflections, because each one is reflecting black, these reflections will just multiply incredibly. The closer it gets, the more these reflections multiply. And the closer you make them, the more hits that'll happen, the more pressure you're going to create between these electrons. Okay? And the red stuff is going to be irrelevant because it's all going to leak out in some perpendicular direction, so it can never get caught in here. So if a red thing comes in and perpendicularly goes in here, it's not going to matter because it's just going to come out some other direction down here. So it can never reflect in here. And so then if I put a proton in that circumstance, you know, with the electron, and I put a proton over here, you can kind of understand that all the red stuff will leak out of the, you know, electron, all the black stuff will leak out of the proton, and you won't be able to build up any pressure at all interior, because there won't be any, it's a straight line force, so no new force can ever get trapped in here. There's no straight line path to getting in there, so it negates the amount of pressure there is between the two objects, and the external pressure, okay, from the field pressure, the normal field pressure, will be more than enough to push the two objects together. So that's how it really works. And again, what's happening inside of an atom, I guess I might as well do that quickly, is, you know, you have electrons and protons in the atom. We can all agree on that, maybe. Well, not all of us, obviously. Lots of lunatics who don't agree. So you have an electron and proton, and just to keep it simple, you know, you have this idea the electrons are on the outside, the proton is on the inside. And so you could sort of understand that the further out I move these electrons, the more repulsion I have between these electrons, the more energy or pressure, the further out they'll end up going. All right, and as they move out, your perspective from a distance of what you're seeing here, you know, how much of this proton energy can get out of here changes as these spread out. You change the profile of the atom, and it becomes either more negative when they're close or more positive when they're further out. that kind of thing. So you can just understand that the visibility of the proton is altered by how close the electrons are. If you just think of the electrons as blocking your view, obviously the further away they are from the proton, the more of the proton you're going to be able to see. Kind of. Anyway, enough of that. Or vice versa. You can look at it both ways. Obviously, if the electron is close enough to me, it's going to block everything behind it. Yeah, I guess I should have done that way. So if I put the electron really close, I'm going to like annihilate the proton from visibility. But if I put the electron closer and the electron smaller, you'll see that the proton is going to show. And that's the principle of pressure. And that's the principle of polarizing the atom with pressure. So the atom changes. It becomes charged, essentially. So it goes from being neutral at a certain distance, positive, and then negative. So the distance decides whether it's a neutral atom, an ion, positive ion, a negative ion, essentially. All right, continuing.
Can be thought of as two equal but opposite charges. Those charges will affect the electric field. But according
So again, will affect the electric field. There is no electric field. There's just the charges doing what I just pointed out, and they radiate to the environment. And when you put the charges in certain arrangements, they're going to radiate red over here and black over there, or different mixtures of red and black. But that's all they can emit is different mixtures of red and black force. There's no such thing as electric arrows and magnetic arrows. There's just the arrows. And the arrows make what are called photons. And they make what is causing gravity, as you can clearly see. Now, the only arrows that can matter to electrons, as pointed out, are the black ones. So light isn't got any of those proton arrows in it. It doesn't bother with those. Because it doesn't move protons, it only moves electrons.
to the pointing vector, we don't get an energy flow without also having a magnetic field. The battery isn't going to lose energy just sitting there.
So again, it's almost like you're saying, okay, so you've decided that there's absolutely nothing imprecise about Maxwell's equations, and so you're going to use these concepts as if they are proven to exist. And as I've pointed out, you can just innately look at it and say it doesn't make much sense on its face to say that a photon is creating is disturbance in two different fields, or an entity that has these two constituent elements of electric and magnetic, when you can't change the path of a photon with a magnetic field. How can it be part of the field? How can it have a constituent in a field if you can't affect its direction with something that affects that field? It just doesn't make any sense. So it can't be. It doesn't make any sense. If you could bend photons with magnets, then you could make an argument. But you can't.
It has to be connected to something. Here's the electric field around the battery again, drawn a little simpler. If we connect some wires in a light bulb, the field will distort a little. Even though the charge in that extra stuff is balanced, it still channels the field through itself.
So this is just more crap in terms of an explanation of why the field would change. The field would change is because you're changing the amount of pressure in the battery. So obviously this field, okay, being created by the polarization of the material inside the battery, is going to change when you start draining the battery. You're draining the pressure out of the battery. You're changing how many atoms, how big the atoms are. And so you're changing their size, which changes whether they're plus or minus. So obviously you're going to change any reflection that's coming off them based on how close or far apart those electrons and protons are.
The field in those materials is strong enough to push the charge along. Now that there's a closed loop, the electric field will cause
So again, he's saying the field is what's pushing them along. He's saying there's not a bunch of pressure inside of this battery, okay, where the electrons are closer to each other than they want to be. Okay, they're creating lots of reflections, more reflections than the external world would have them be in. So we've contained pressure in the battery. It's reflecting off the outside of the battery, however you want to look at it. It can't get out. And the only way it can get out is it has to leak out through the conductive ends through the medium. So the battery does slowly discharge through the atmosphere, but the voltage is low enough that it can't do that very effectively. It's not enough currency. It's throwing out little 10-cent bits of pressure.
Steady current, and where there's moving charge, there's a magnetic field. So now?
So just more, again, this doesn't illustrate anything mechanically. He's not talking about the function of atoms at all. It's just totally just silly little animation pictures saying, I'm saying there's a field here, I'm saying there's this, there's that. When, yes, there's the effect. Like I said, when you're putting current through atoms, okay, you're changing their pressure. So when current's moving through a wire, it's changing the pressure. Atom A has got 20 pressures, atom B right next to it's got 5. Both of them become, well, 25, half of 25. It's not a great number to use. 12, 13, and 12. I'm just saying they equalize out. So the pressure's being exchanged. It's you can call it flowing, but they're just exchanges.
We have an electric field and a magnetic field. According to the Poynting vector, we get an energy flow. But this cross product means the flow has to be perpendicular to both fields. The flow of charge is the same direction as the electric field.
And all this perpendicular crap means is that they're wrong lines they draw. Okay, you're perpendicular to those lines, but I'm just saying that these are not lines of force. These are field lines. These are lines of the strength, how many red or black arrows you're getting hit at from a certain location. It doesn't give you a description of what direction those arrows are moving in. So of course they would move perpendicular to your line because they're moving straight and you're measuring. Measuring is like hitting a brick wall. So yes, the brick wall has to be perpendicular to the force hitting it. Okay, but we know the force's direction isn't going to change if it's not really a brick wall. So you have a test wall, a piece of paper, and you watch something fly through the piece of paper. Obviously the thing flying through the piece of paper will leave the paper perpendicularly.
Which can't be the same as the flow of energy. According to Poynting, the energy cannot flow in the same direction as the charge.
Well, so of course that's only because they had to break what Benjamin Franklin did that was wrong. So he's only saying that if you accept that positive and negative have been wrongly assigned in terms of which end actually has the pressure. And so that's the only way that makes sense. And you're saying I'm going to pretend they didn't fix that, and then you're going to make an argument based on an unfixed foundation. It's just stupid.
Wait, what? Exactly. When I realized this, it broke all my intuitions about circuits. But here's what everything...
It's not intuitions, it's knowledge of the flawed history, and knowledge that 200 years ago they didn't know how this worked. Okay, they didn't know these mechanisms. We know the mechanisms now. We know there's electrons and protons. We know they're charged entities, and we know that they have these inverse properties, that what affects an electron doesn't affect a proton, and what affects a proton doesn't affect electrons. We know these things. They didn't know that.
It looked like when I put it all back together. If we zoom in on one of the wires a little, we've got a strong electric field inside moving the current along.
Okay, it's not a strong electric field inside. So this is where it gets even dopier, because it would be one thing to say it's creating something like a magnetic field, but they think it's creating some sort of field in here. There's no field inside the wire, there's just electrons. And when you push electrons next to each other, you can understand that one electron moves and the other electron will move and the other electron will move. Or you could understand that if this was the idea of moving meant you moved closer to the proton, so this electron pushes out because it acquires momentum. It pushes against another electron that pushes closer to the proton, which polarizes the atom. And the next atom's doing the same thing. So now you're changing the shape of the atoms as you move the pressure of the electrons through the material. And in a conductor, that pressure moves really easily, and in an insulator, the pressure, the atoms are so situated that when the electrons move, that pressure doesn't bump into the next electron, so the pressure stays here, it reflects, and so it stays on the surface.
In the little electric field outside, we also have a magnetic field inside and outside. Using the pointing vector, we get an energy flow toward the center of the wire. The energy comes...
So again, this energy flow. Using a gimmick, we get a gimmick. And that's all this is. There's no energy flow into the wire. None of that crap is happening. It's all just a mathematical gimmick.
From the field outside the wire. Wait, didn't you say earlier that the energy comes from the battery? Yeah, but it happens indirectly. Inside the battery, the electric field points the opposite way, but the magnetic field points the same way. If we look at the battery the same way we did the wire, the energy flows out of the battery and into the field. So the energy the wires and light...
Right, so he's basically arguing that the energy doesn't flow through the conductor. That is, the electrons don't pressurize each other and move it through the conductor, the atomic structure, that somehow the energy is going into the field, and then from the field it's going into the conductor. So he's doing some kind of Tesla-esque kind of horse shit. That's just horse shit. The other thing to point out, all right, look, the magnet thing happens, and that's a byproduct of the process, okay? So it's not like the magnetism requires any extra function from this process. So it's just this idea that in certain materials, they're already polarized. All right, they already have a relationship between the proton and the electron because of the way the atom is structured that's imbalance. All right, that means that there's more electron, however you want to look at it. There's a weight of the atom. The atom has a decidedly positive perspective and a decidedly negative perspective. Looking at it from one way, you'll see the black. Looking at it from the other way, you'll see the red. And those atoms are arranged in all kinds of different orientations, you know, red to black, inside the material. And that when electricity flows through it, those different relationships, okay, where they're organized kind of helter-skelter-y, all right. Sorry, it's not in the picture, but anyway, changes, so it's all ordered. You know, they're all lined up. You know, red, black, red, black, red, black, red, black, red, black, red, black. You know, and the more ordered you make them, the more magnetic it becomes. But the magnetism is again the same effect. It just has to do with the outside field hitting something and either being reflected or diverted. And what magnets are obviously doing in the big picture, all right, if I draw a magnet here, is, you know, all the red energy coming in here goes out here. All the black energy going in here comes out here. Right, so then let's just remove the going ins now, and you can get the idea that combined with the fact that any red energy that comes into the, well, I should have had this red. I erased the wrong ones. Sorry. Just confusing the image a little. I'll just erase it. All right. So as I pointed out before, so that's what's happening when opposites come in. And then when the same color comes in, we know it just reflects. So that looks like just going out too. So the red end becomes all red, and the black end becomes all black. Now, the point is you can have different densities of that function in the sense that the magnet can be more and more perfect, the material, but it still only has a certain number of atoms. So you need the atoms to be polarized, and then you need the material to be such that you can get to all the atoms and make all the atoms polarized. But it's just a filter. It's just taking what's coming from the outside and changing it. So the more perfect I make this, the stronger the magnet will become, but it's using no energy from the electric current. The electric current that makes these atoms line up. Okay, so I'm sort of giving you the iron explanation here, but the point is in a regular conductor, you're doing the same thing. The more electricity you force through the current, the conductor, right? So you have a conductor, and you're pushing this pressure through, and you're changing these, you're doing these exchanges I talked about. Well, as I pointed out, the more current you put through, the more of these atoms will be involved. The more atoms that are involved, that means the atoms are constantly changing from a plus condition to a minus condition. As the current moves through, the atom becomes fat, it becomes thin, it becomes fat, it becomes thin. It's constantly changing its condition. And so the more atoms you involve in that changing of condition, the more you're making sure that every atom in the material ends up being polarized. And so then you can have a maximum amount of magnetism. But you can't convert the electricity directly into magnetism. It's always a byproduct of the process. So when they pump a bunch of electricity into electromagnets, they super cool because it's all heat. So they have to get rid of all the heat. So they have to make it as pure a conductor as possible so they generate no heat by moving the current. But the magnetism is just a byproduct of the current's flow. Still current flowing. You still have to use the electricity to change the configuration of the atoms, but the atoms are just acting as a filter. So that's why you can't just boost the power, and boost the magnetism. You get to a certain amount for the density of the material. So you have to make it a bigger conductor and shove more shit through it to make a bigger magnet. So your magnet's going to be dependent on how much current you can flow, and how much current you can flow is dependent on how many atoms there are to arrange. But the more perfectly you arrange them, the stronger the magnet. So like you can have an N30 magnet, or you can have an N50 magnet. You can have different strengths of magnetism based on how pure these arrangements are. How many of the atoms you got facing north to south in exactly the same arrangement. The magnetism is a byproduct. It isn't using energy. You don't use any energy to move them the wrong way, any more energy, to have them move the wrong way and then to have them move the right way. It just is an incidental fact that when you're exchanging pressure between atoms, you're polarizing the atoms. And you're turning them into mini magnets.
A bulb gained from the field is the same amount of energy that the battery loses to the field. The energy flow.
So this is just obvious. Well, you could just say the same energy that it was in the battery goes through the wires and creates heat, or does this other stuff because of the impurities in the wire. So we clearly know the energy is moving through the wire because that's where the heat's created. There's no heat created in the atmosphere. So he's basically implying here that the energy doesn't flow through the wire, that it goes into the field and then into the wire. And there's just absolutely no evidence of that. And it wouldn't work over distance and all those things that make it just obviously not the correct answer. It is not a change in the field. There's no Tesla theory here that makes any sense. You cannot put energy into the atmosphere over here and collect it over here. You need a conductor. And so this is just horse shit.
Oh, in this circuit looks like this. It's cray-cray. It doesn't even...
It's cray-cray. No, it's fucking stupid. You're being stupid, you're teaching stupid, and people are consuming stupid. And that's really depressing.
It doesn't matter if it's AC or DC. With alternating current or AC, the current just moves back and forth because the electric field keeps switching directions.
Right, so again, from my example, it just means that obviously the pressure, okay, this side is where the guy with $20 is 1 minute, and then the next minute this guy over here has the $20 bill, and I'm sitting here with my 10. So I'm obviously just going to keep switching.
What is the magnetic field? If this changes direction, and so does this, the two effects cancel. The energy flow maintains its direction. Even in an AC circuit, the energy flow is out of the source and into the devices. How could that possibly be?
So again, he just drew this little silly animation, like somehow it's going into the field, and then the field, it goes into the wire, and then, which doesn't make much sense, right? And then was it doing the wire, but pop back out of the wire again, go into the field, and then go into the light bulb? I mean, it just doesn't make any sense.
B, aren't AC generators like miles away? Yeah, but that's totally fine. Remember, these fields are everywhere. In effect,
so he's saying it's perfectly fine because somehow the field is everywhere. Therefore, I can, again, like Tesla's thought, I can shove power up here, over here. I can just shove it into the field, and I can pick it up anywhere I want, and somehow the field wouldn't completely eat whatever I put in there, and it wouldn't go as a lightning strike somewhere else. I can't make a lightning strike and then assume, well, I might have changed the polarity subtly between this part of the atmosphere and this part of the atmosphere, but I haven't in any way prevented it from being used where I didn't intend it to be used. That is a discharge and a lightning bolt in New York City. So all I did was make a lightning bolt in New York City more powerful by shoving a bunch of potential into a cloud in Wyoming. I mean, yeah, I can shove some energy into the clouds in Wyoming, but I'm not going to be able to pull it back out in New York, because in Chicago there's going to be that cloud's just going to discharge, and just that extra potential is going to go with it.
By all charges everywhere. The energy coming out of a power source doesn't have to be the same energy going into your devices.
So again, it's just kind of silly. We already know it's not the same energy, in the sense that it's pressure. So you have to move the electron. When you move the electron, you've basically exchanged the momentum. You did the opposite reaction thing. You gave something momentum. So you wouldn't say the energy that, if I was to shoot a missile to the moon or something, you wouldn't say it's the same energy, that I used in the rocket engines to get the missile to move through the space that hit. But yeah, I mean, technically it's just momentum. You've taken one form of momentum and exchanged it into another form. If I hit something with a baseball bat, and its head flies off, boy, it's a nice thought. It's you're not worried about, well, it's not the wood of the bat, that's still in his head, that's making his head move. There's obviously some other element that's moving.
Conservation of energy just says they have to be the same amount. If you calculate the amount of energy flow across the surface of this wire, you will get exactly what you'd expect for the power.
So it's just a gimmick, all right? It's just a gimmick. So the amount you're going to change, the amount you're going to magnetize a wire by throwing a current through it is going to be completely proportional, all right, to how much you're going to lose in the wire, because they're not perfect conductors, and proportional to what you get at the end. The amount of change you make in the wire is proportional to the current, and the current's changing the magnetic field by changing the polarity of the atoms. So the amount of polarity change is going to be completely proportional to the amount of watts you're attempting to move through the wire current. I mean, without losses, it's, they're all the same term, but whatever. Let's just continue to the end here.
Power lost to heat and light. So how does the energy actually flow in a circuit? The energy that makes a
So again, his equation, he had to say, qualifies to heat and light, whatever stuff you're losing from the imperfectness of your conductor. So he had to say, well, the equation works, except you got to account for these losses. And so the equation is just saying there's a relationship between current and magnetism, and we already know that.
Circuit work comes from the fields around them.
The magnetism is not work, so that's the part you have to understand. The electricity is not being converted into a magnetic field. It's just changing the atoms into magnetic atoms, and just like a regular permanent magnet, it doesn't need any energy to be magnetic. It's just arrangement that makes it magnetic. All you have to do is rearrange an atoms to make them magnetic. You don't have to put energy into them.
A source of energy like a battery just replenishes what gets used, and all the electric current does is provide the mechanism we need to make the energy flow.
So again, it's just gimmicky horseshit. There's no validity to any of this horseshit. The fact that there are emergent properties, the fact that there's consequences to current flowing through a wire, doesn't mean those consequences are a representation of what's happening in the wire. The wire's where the energy's moving, the pressure, the momentum. All the momentum is in the wire. The only thing you've done by putting momentum through the wire, by moving electrons, is you've changed the orientation of the atoms, which now makes the conductor magnetic proportional to that. And the fact that there's a proportional relationship, so a field change happens, but the field change isn't the energy, it isn't the pressure. The pressure does not move out of the battery into the atmosphere and then move into the wire. The pressure that's in the battery goes right through the wire. It's just an extension of the battery. The conductor is just essentially an extension of the battery. You're just making the battery bigger till you get to your place where you're actually going to do the wattage work. I mean, think about it logically. Isn't that all you're doing? I mean, fuck. When you put a conductor on a battery, what are you doing? You're just extending this pole. You're just saying, I'm taking this pole and putting it over here. I'm putting it over here. I'm just lengthening the pole of the battery. Shit.
So are you as mind blown as me right now? Please share in the comments. Thanks for liking.
There's no, but yeah, and most of the comments are whatever, affirmative, because of the way the idiotic YouTube ranks them. But he did pin this one. I seem to have made educational choices. So this is the funny part, right? I mean, he's preaching this as a discovery of some real phenomenon. I've proven Tesla right. And he didn't mention Tesla, of course, but that's what he's basically trying to say here, is that Tesla's fundamental theory was somehow correct when it was demonstrated to be fundamentally wrong. But anyway, choices in this video that some viewers feel are mistakes. They're perversions of the truth. Yes, you've built a straw man physics. It's crap physics. It's junk as physics. You keep changing the goalposts. One minute Franklin's right, the next minute Franklin's wrong. You keep changing them to change the game. They're not mistakes. They're worse than that. They're deliberate connivery. But I'd like to take a moment to clarify so you can understand why I made them. Now, there's no understanding it beyond the fact that you're attempting to do something shock and amaze with a trick. Bullshit. It's not even a good trick. It's a fucking magic trick you get in a freaking Cracker Jack box. I know the potential across the surface of a perfect conductor should be 0. So the electric field should be perpendicular. Again, this really doesn't have to do with the perfection of the conductor. It has to do with whether you think the actual function is the movement of electrons, and where do the electrons move? They move inside the fucking wire. But there's no such thing as a perfect conductor. It doesn't matter. So again, it doesn't matter whether there's such a thing as a perfect conductor. All that matters is that you're just playing a game with equations that are imperfect. The equations are already start off imperfect because of Benjamin Franklin's wrong assignment. The equations should fix the wrong assignment first and then try to write equations. So first get the assignment correct, and then rewrite Maxwell's equations. And maybe when you do that, you'll find out there is no such thing as an electric field. Materials on a spectrum, which is something I've been saying since this video. So whatever, that doesn't fix any of this horseshit. How perfect the conductor is has nothing to do with you playing some game that somehow the energy isn't moving through the wire when it is. I'm aware that the directions of my vectors are not perfect. As I said in point number 1, materials fall in a spectrum. So again, he's saying, yes, the direction going inside the wire is crap. That somehow the energy is moving into the wire and out of the wire instead of through the wire. Yes, obviously you've gotten something wrong. For clarity, I choose to omit some components of the vector because they distract from the main takeaway of this video. Energy throws through fields, not wires. And the main take is absolute nonsense. The wires get hot, the wires are doing the activity, the change in the atoms is happening in the wires, and the change in the atoms is exactly why they become magnetic. They can't become magnetic unless, they were changing the atoms. It's just idiotic. Your whole theory is crap. At 5, I say we've got a strong electric field inside the wire and a little electric field outside. Strong and little are very relative words. Broadly speaking, all the fields are dealing with in this video are weak. So there's nothing weak about the pressure that you could put in the wire. However, in the context of the circuit, what matters is how those fields compare only to each other. It matters to you, but it's not logically meaningful. The fields have to be created by something. You can't change the field unless you change the electrons and the protons. The electrons and protons are defining the field. What they are reflecting is exactly what the field will be. And we're just saying that if you change the position of electrons and protons, you'll change what they reflect. The electric field inside the wire might be weak, but it's stronger than the electric field outside. Maybe I should have said stronger instead of strong, but I don't really think that's worth getting upset about. I think the point to get upset about is your implication that somehow the field is where the energy went. And no energy went into the field. The energy of the battery's potential went through the wire. It didn't go through the field. The change in the field is incidental to the function of the flow through the wire. If there's no flow through the wire, there's no change in the fucking field. The wire's just an extension of the poles of the battery. The battery's exactly the same amount of pressure. You're just extending where the pressure goes. Alright. So, as a physicist, I approve this message. Best explanation I've seen so far on the internet so far. I've seen so on the internet so far. So he didn't even fix his error there. He can't even, as a physicist, he doesn't even want to fix his grammatical errors. I mean, best explanation I have seen so on the internet so far. I mean, obviously broken, didn't bother to fix it. 244 thumbs up for that crap. That crap statement by a physicist. As a physicist, I understand that wires don't get hot and wires don't indicate that something's happening inside of them at all. I mean, if the flow of the energy wasn't through the wire, and we already know that it's impurities in the wire that make for heat. So the more perfect the conductor just means you want to have a material that doesn't have impurities in it, and then you want to make it as cold as possible. We already know this shit. So why do you think the field is where the heat's coming from? Because it's not coming from there, idiot. Jesus. Oh. Well, anyway, there's just no point. These people are just too fucking stupid. Let's see. Alesno Viola should also be complaining then. Let's see what this Peter Jacobs says. Well, no. Yeah. My name reminds me of... So this guy's just doing what my name... But your lecture is not quite correct. The unit of capacitance is a farad based on the name. So now they're talking about some other subject. Oh, there's no point. This video is one of the best and most clear examples of why your channel is unique and different from all the other science channels out there. Well, it's very much like a, Eric Dullard or Ken Wheeler. It's craps physics, presented in a crap in a way. I don't even know what to say about the bullshit animations. So anyway. They're talking about rubbing amber, it's a girl. I mean, it's jokes, idiots. Anyway, it's just no point. Why? Just give up, Gary. They're too fucking stupid. They're belligerently retarded. They look belligerently retarded, and they are belligerently retarded. I'm just thinking male patterned lobotomy. I mean, it's like they all have had lobotomies. You're all just... Huh? There's no point. But there's no other... There's nothing else to do. There's nothing... if you go to a planet and it's covered with retards, I mean, all you can do is keep arguing with the retards. You got no choice. So anyway, till next time, so depressing.